This question is actually from an old practice SAT before they went digital, and I would teach this question quite a lot. Everyone will get it wrong for pretty much the exact same reason. So I will point that out when we get to that spot. But it's still a percentage question, so we're still thinking about the open formulas. So let's take a look at the story. The manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. How many subscriptions did the manager expect would be sold in 2014? So first, we have to work with what we got, right? We need the percent increase from 2012 to 2013, and those are the only numbers we have. So let's use the open formula, right? So let's do it up here. We're going to do O times 1 plus or minus P equals N. I know that I'm using that particular open formula because it says percent increase, right? So they're really giving it to me, and they say from 2012 to 2013. So they're telling me just follow the normal order of the original is the first date and the new value, the N, is the second date. So that means 5,600 goes here. We don't know the P, and we have the N as 5880. So calculator time, let's divide both sides by 5,600. I should have written this somewhere else. This is getting pretty smushed. So 1 plus P, I'm going to use a regular old calculator here and do 5880 divided by 5,600. And I get 1.05. Finish the job. Don't think about it. Solve for P, right? So 1 minus 1, we get P is 0.05, which is 5%. Okay, so everything so far totally right. Then what's going to happen is we say, okay, the manager estimated the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. So what most people are going to do, and it's wrong, is they're going to double this and go to 10%. But again, this is wrong. If you do that, I think one of these answers is what you would get. So you already might know if you did that's what you did wrong, right? So the reason we're not doubling this is that's not what it says, right? The manager estimated the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. Even though they're using the word double, they're telling us to divide it in half, right? They're doing it backwards. And one of the most amazing skills that we can use on the SAT, basically we already know to arithmetize, right? We know to get rid of variables and put numbers in place of variables, to plug points into equations, right? That's our main math strategy. But we can even do that in sentences that are hard to understand, right? So let's plug points into equations, into the sentence itself. The manager estimated that the percent increase from 2012 to 2013, that's an unknown, a variable, that now we have a point that we can plug in. That's 5%. So throw it in there, right? So the manager estimated that 5% would be double, and we think it's 10%, right? So throw that in there. Think about that sentence now. If we throw in what we thought it was, right? The manager estimated that 5% would be double 10%. 5% is not double 10%. 5 is not double 10. 10 is double 5, right? So it's backwards. So I think if we plug those numbers into the sentence itself, it becomes very, very clear that this is not right. And this is one of those things that you should see coming. This question on that practice test that I was talking about, that old practice test, it was near the end of the section. It was exactly where you'd expect hard questions to be, questions involving tricks and traps. And most people who fell for this particular trap didn't think about that. They weren't thinking like, let's just be really careful here. They might be messing with me. So anyway, all of this is to say that 10% is wrong, right? We want to divide it in half. So it's actually 2.5% that we want. And if we plug that in the sentence, it makes much more sense, right? The manager estimated that 5% would be double 2.5%. Yes, 5 is double 2.5. That does work. So that is our percent increase from 2013 to 2014. And now we've got to use the open formula again. And we're going to just come down here and we'll do it again. And now we have slightly different values, right? We have the original, which is 2013, right? They gave us that. It was the new before. Now it's the original because now we're moving forward in time, right? So this is now 5880 here. We now know the percent is 0.025, right? That's 2.5%. So make sure you get those decimals right. And we're solving for 2014, which would be the new value, okay? So now it's a simple multiplication problem, but most people, again, would not be doing it right because they don't have the right percent. Now it's just a matter of popping it into the calculator. So 5880 times 1.025 is 6,027. Is that an answer? Yes, it is answer B, and that is the correct answer. I love this question. I love it. I love it because in a lot of ways, it's very simple. It is a plug points into equations question, right? We have an equation that we are supplying ourselves, right? We are supplying the open formula. We know we have an equation for percents we've memorized. So we're providing that ourselves. And then we are plugging the points in and just everything kind of goes where we'd expect it to go. But also it has this kind of like, more big picture meta plug points into equations idea of like, kind of try to understand when they're using variables or unknowns or kind of empty language to distract you, and see if you can bring everything back to numbers. That's the entire point of plug points into equations, is we want to bring numbers back into math. We don't like having letters. That's not as easy of math. So if we bring numbers back, we're able to understand things better. That's true in equations, but that's also true, like in this case, in that sentence. We plugged it in and we made sure we didn't make the mistake. Now, if you didn't make the mistake and you think I'm making a big deal out of nothing, feel free to comment. But I'm telling you, I taught this exact question probably 1,000 times, and in way more than half of people got it wrong for that exact reason. They would say that 10% was the number because they weren't reading carefully. And so many problem solving and data analysis questions, so many percentage questions, so many hard SAT questions stop being about math and are really about reading carefully. Did you see that one little word that changes it from an increase to a decrease, or from a normal percentage to an increased percentage? All those things matter, and that's what the open formulas are meant to do, is keep us on track. But sometimes we just got to overall be thinking about those kinds of potential traps everywhere that we expect hard questions in the SAT.